Morning student. Today lecture laboratory experiment cities and bachelor degree honors course or this syllabus laboratory experiment here. One of them is the determination of given solution by a standard solution. Today I will give you an example of conductometry solution against HCl. You can find in the PT we have HCl NaOH standard solution. No, HCl is a strong acid, strong base. This reaction will occur. What are the card will be there? Discuss. Before starting, introduce myself. From Hyderabad College of Engineering. You go to the website. There is any query. Don't hesitate. So the aim is determination of strength of HCl. This is the strength of HCl of strength. HCl. As we know, HCl is a strong acid, but it is a secondary standard. We know that the secondary standard are those which are changing their concentration very easily in a very short period of time. But for the to change the concentration of primary standard takes time. Maybe week, it may be month, depending on the nature of the chemical. As it is HCl, so we have to know the reaction is that HCl is reacting with this. NaCl will be there to form. For this here is you can find in the volumetric class we have to take the oxalic acid N/10 solution approximate. Applied solution will be NaOH solution, supplied a solution, and apparatus we have to take in volumetric flask, etc. As it is a conduct titration, so we have to laboratory meter. Okay. So if we do the conductometric titration, we have to compare with the regular titration method, know the concentration HCl. We have to compare between conductometric HCl titration, also the normal regular laboratory case of using phenolphthalein indicator. For this, we have to take a first reaction. Is laboratory, we have to take a table. This table is for determination of strength of HCl, oxalic acid solution, and the oxalic acid solution is why it is used. As you know, oxalic acid is a primary standard. It don't change its concentration easily. That is why you have to take the concentration of, you have to prepare the N/10 solution here, N/10 solution of oxalic acid. How we can prepare? We have to take a initial weight, final weight, then for the n by 10 you have to how much we have to take n by 10 you have to we cannot make n by 10 exactly. There is will be a factor in front of this n by 10 solution. Okay, so oxalic acid will be prepared range of n by 10 with a factor. And why it is oxalic acid? Oxalic acid is taken because it is a primary standard. It don't change it easily. Okay. So as it is acid, so it will be second table you can find there will be base. We have to take the titration against a base. For this we have to take first table. We have got the concentration of oxalic acid. So we have taken here the 10 normal or 10 cc of or 10 ml of oxalic acid. 1 2 3 4 number is our observation. From burette we can easily get the mean value of the NaOH. So using V1 S1 V2 S2 formula you can easily get the strength of NaOH in the range of n by 10. As it is oxalic acid strength is n by 10 the range, so it will also be in the range of by 10. There will be a factor of NaOH. Okay, so from the table 1 we have got strength of oxalic acid. From the table number 2 we got the strength of unknown NaOH. The next table we will go is that determination of strength of HCl. What you will find it and find in the table number we will take 10 cc of HCl. Burette reading you will get the as it is burette of NaOH 1 2 and 3. So get the strength of volume of the NaOH as from the table number 2. As we know the strength of NaOH, so using V1 S1 V2 S2 you can easily get the strength of HCl by using indicator. Okay, we have phenolphthalein, we have methyl orange, so you have to take here methyl orange indicator. Or number 2 take phenolphthalein as indicator because strong base with acid, so you can easily get the endpoint. Okay, and in the table number 4 this is separate titration. It is not titration, it is a conductor. Using the that we have to take the volume. You have to add the volume, a number of drops here. You have to find the temperature. As you know the conductance depends on the temperature, so you have to find the temperature. You have to take 10 cc of HCl in a beaker and make it to a certain level so that conductometric electrode dip the HCl. You can find there will be a graph. You after adding 10 drops or 20 drops of each time NaOH you get the value. Conductance, if you plot this conductance against the you can find this kind of graph. Here you can find HCl is a very strong acid, so the conductance will be very high because H plus and Cl minus is giving you high conductance. This will be very high, and when we are adding NaOH, that is NaCl is sodium, H is replaced by sodium, so conductance will be low. This is the decreasing value with the addition of NaOH. After the addition, when there is no HCl, due to NaOH, OH minus has a strong conductometric value. This value is why a V-shaped card will be there. From this V-shaped card, the endpoint will be there without using the indicator. Here is the indicator, there is a endpoint, and from this endpoint you can easily convert the number of drops into a volume. So using V1 S1 V2 S2 again we can get the strength of HCl. So if we the table number 5 verify the strength of ACL. Suppose you have taken the strength of ACL by normal titration method, then conductometer we can also get. And if the ratio is 1, you can find, so you have good job by ACL, because the ACL is not change. It is the concentration of ACL for titration and also conduct titration is same. So from conductometric titration, the strength will be the same with this. We have to verify these two whether they are same or different. If it is 1, so you can find what you have done. We checked the table. Okay, so this is a good experiment to get the 100% accuracy. Thank you everyone. If you have any suggestion, you can comment on the like suggestion.